Hi everyone, welcome to another Fireside chat. Here we've got Lee, the founder of Hydro Wind Energy, and Mo, who's the head of digital strategy. And we're going to be talking about specifically about the product, how it became to be Quenchsea, how we've got to this point in the journey. And also Mo's going to be talking about some of the comments about the product, what you like about the product, what you don't like about the product, and we're going to try and address some of those comments. So to start with, Lee, how did you come up with the idea? How did it all start?
Well, we're already working the desalination in any sector, and we're developing an offshore-based technology to solve the world's water crisis, but at scale. And we were just, me and some of the team, especially Hike, who's the CTO, we were just kind of discussing the idea of creating a small device that can be used low cost, that can be used to desalinate seawater into freshwater, especially using what they call reverse osmosis, which is a process they're currently using in conventional desalination plants. Mm-hmm. But the idea was something low cost, something that could really make an impact globally. Because the reality is that, about 2.2 billion, according to the United Nations, 2.2 billion people don't have access to clean water globally. So yeah, that's how the whole idea of developing Quenchsea started.
That's great. I think what's really interesting to me about Quenchsea is you've specifically made it manual so that anyone using it doesn't have to rely on anything except their own ability to pump the water. And I think that really makes it different from any other desalination solution, because it's that ability to empower someone to get the water themselves.
Yeah, that was also, the power source had to be human power. So you could use it anywhere, whether you're in the ocean or on the coast. You don't need an external power source, and it is very difficult to desalinate seawater. I do want to mention that there is one device that probably has existed for it's no longer on the market, and it's called the Cadian 06. Which was developed by a Swiss company, but it was developed for the military. So it has been, but it cost $1,000. So it's really inaccessible to the majority of people. I mean, you can get it in life rafts sometimes, on cruise ships, but it was developed for the military. And we're saying now, 20 years down the line, we say, is there a way, that the market, I think timing has been also, good for us, because reverse osmosis membranes, the costs has actually gone down in the last 10 to 15 years, and we said, let's see if we can do something that's happening in large scale desalination plants into a small scale device, but at low cost.
So Mo, what's kind of been your perception from the comments? What do people love about Quenchsea?
So I think there's mainly two kind of aspects to it. So there's a kind of adventure side, and there's humanitarian side. So a lot of people think that actually this is an amazing idea. It's quite cheap, and they'd love to take it on their boat or their kayak. So a lot of people who are doing type of adventure stuff around the sea, out at sea or on the coast, are really excited about it. There's some people who've got non-profit organisations who are interested as well. So I think there's a bit of both. But a lot of people do or have commented about the fact that we're donating one Quenchsea unit for every one sold, who have really kind of admired that.
And I'm really interested to hear about the whole kind of product development journey, because as is inevitable, especially when you're trying to do something so kind of revolutionary, there's got to be kind of hurdles along the way, new challenges that arise. So what was that process like for you, Lee?
No, it was. We definitely had loads of challenges, but the core of the technology, and because people were asking on social media, is that right, Mo? Oh, how is this possible? The reality is the basis of this technology is the simple hydraulic system. I think we've all done physics, in our GCSEs. We've used the hydraulic system. And actually the first, one of the first prototypes that we built, the basis of it is a hydraulic car jack that, it has oil inside, but we adapted that, and we used the hydraulic fluid itself is seawater. It is that, in essence, the ingenious part of this device is that we're using something that's already being used in so many other, from whatever inside your car, in bottle car jacks. I mean, the hydraulic system is part and parcel of everyday life. It's almost in everything we use. If it's a mechanical system. I mean, your background's mechanical, and you're a mechanical engineer, so you know that, Hannah. Yeah.
Yeah. Gosh. One thing that really interests me about that, actually, just coming onto the I think this has been a comment on it on social media as well, Mo, you have to agree, but I think the thing that I think people are most intrigued by is the fact that, of course, we need a long lever to get the leverage to allow it to be comfortable standing, but most importantly, to get the power. And I think what must have been a really big challenge for you is identifying how we get this like really long stick basically into this compact device. So explain kind of that process and how you came up with the like kind of concertina.
Yeah, well, the reality is, because this device, what tends to happen is it's a hydraulic system. So your human force has to create a pressure of up to, about 60 bars. So just to give you an idea of what 60 bars is, that's equivalent to having, on every centimeter squared of your body, it's almost having 60 kilograms on each centimeter square of your body. So we have to create that amount of pressure in this small device. So the hydraulic system is already a mechanical advantage system. That's, standard physics again. But the lever also makes it easier for you. The longer the lever is, the easier it is to kind of pump. So that means we've got two. So the longer it is, and we wanted to make it as easy as possible for people to pump it. Whether you're a 12-year-old or whether you're 70-year-olds, we just wanted to make it so easy for you to pump it. But remember, that pumping will create inside that system a pressure of up to 60 bars. Because in order for you to remove salts out of water, you have to have, it's a minimum of about 55 bars. And that's why the lever is so important. So we've designed it in a sense that it's extendable, that also you can stand on the whole system, and it's simplify it to pump it. We've tried different variations, and that actually worked out to be the best system to use.
Cool. So I'm going to ask a couple more questions as we run up in about 5 minutes. So Mo, the next question I have for you is that a lot of people have been asking on social media about the filters. So I thought it'd be good just to discuss that. So what has kind of been your main answer? What are the main kind of conversations with people you're having about the filters?
That's really weird, because I was actually thinking about the filter right now. So
great minds.
A lot of people obviously want to know what is the lifespan of the device, whether it's being used or not. It's primarily intended as an emergency device. So you might have water with you, but you've run out of water, and this is kind of your backup option. And also to be used in humanitarian scenarios. So it could be a disaster somewhere and we want to quickly roll out water. So rather than delivering bottled water, you deliver a quench device. So the question is, how long does the membrane last? And it's a good question. The answer we've been giving is basically that it depends. And the factors that are going to affect it are the temperature, the quality of the feed water, pressures, and also how clean is the water that people are using. So if they're using clean seawater, then it should last for longer. But I think the main thing to kind of highlight is, regardless of all these points, the actual cost of replacing the membrane is very cheap. It's around $10. So theoretically, someone can go out and have their backup membrane or filter ready for the next change.
And finally, Lee, to round us off, go out with a bang. What does the future hold? So what are the next steps, and why should people get involved now?
Well, at the moment, what we're trying to do is really build the momentum, because this project is really, it's about the humanitarian. There is a market for it in terms of sailors, campers, hikers, and survivalists. So that is a market, and that's why we launched on Indiegogo, because, these are the first adopters. But the idea really is to make a global impact over the next 7 years. And we've already pledged, to donate 100 million units of these to people in need, because we really want to make an impact globally. So, we're looking to deliver the first batches probably before February 2021. We'll probably do it earlier. But I think that just gives us enough room because of, the current circumstances with COVID and things like that. It does affect logistics and delivery times. It's looking positive. We just want people at this stage, and I know we've thought about that, is to either buy, donate, or support what we're doing. Not necessarily, they don't have to buy it, but just supporting it or sharing it with friends and family. It will help us in terms of the bigger cause.
Okay, thanks, Lee. Thanks, Mo.
Thanks, guys.
And thanks everyone for watching. And get Quenchy on Indiegogo now. Okay, bye.
Cheers. Thanks.